Good day everyone, I am Stephanie Grace Hiton and I'm going to discuss about cyclic group. So cyclic groups are groups in which every element is a power of some fixed element. If the group is abelian and I'm using positive as the operation, then I should say instead that every element is a multiple of some fixed element. Here are some relevant definitions. So, let J be a group J element of J. The order of J is the smallest positive integer n such that J to the power of n is equal to 1. If there is no positive integer n such that J to the power of n is equal to 1, then J has infinite order. In the case of an abelian group with positive as the operation and 0 as the identity, the order of J is the smallest positive integer n such that nj is equal to 0. So, another definition is, let J in a group and J element of J, then the subgroup generated by J is J equal to J to the power of n, where n is the element of Z. If the group is abelian and I'm using positive as the operation, then J is equal to Nj, where n is an element of J. So another is, a group J is cyclic if J is equal to J. For some J element of J, J is a generator of J. If a generator J has order n, J is equal to J is a cyclic of order n. If a generator J has infinite order, J is equal to J is an infinite cyclic. For example, the integers at the integers mode n are cyclic. Show that Z and Zn for n is less than 0 are cyclic. Z is an infinite cyclic group because every element is a multiple of 1 or of negative 1. For instance, 117 is equal to 117 times 1. Remember that 117 times 1 is really shorthand for 1 plus 1 plus plus 1 minus 1 added to itself 117 times. In fact, it is the only infinite cyclic group up to isomorphism. Notice that a cyclic group can have more than one generator. If n is a positive integer, Zn is a cyclic group of order n generated by 1. For example, 1 generates Z7 since 1 plus 1 equals 2. 1 plus 1 plus 1 is equal to 3. 1 plus 1 plus 1 plus 1 is equal to 4. 1 plus 1 plus 1 plus 1 plus 1 is equal to 5. 1 plus 1 plus 1 plus 1 plus 1 plus 1 is equal to 6. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 is equal to 0. In other words, if you add 1 to itself repeatedly, you eventually cycle back to 0. So a cyclic group of cycle 7. Notice that 3 also generates Z7. 3 plus 3 is equal to 6. 3 plus 3 plus 3 is equal to 2. 3 plus 3 plus 3 plus 3 is equal to 5. 3 plus 3 plus 3 plus 3 plus 3 is equal to 1. 3 plus 3 plus 3 plus 3 plus 3 plus 3 is equal to 4. 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 is equal to 0. The same group can be written using multiplicative notation this way. G7 is equal to 1, a to the power of 2, a to the power of 3, a to the power of 4, a to the power of 5, until a to the power of 6. In this form, a is a generator of Z7. And it turns out that in Z7, 0, 1, 2, 3, 4, 5, 6, every non-zero element generates the group. On the other hand, in Z6 is equal to 0, 1, 2, 3, 4, 5. Only 1 and 5 and 5 generates. Thank you for taking time to watch this video. I hope that you've learned something new about cyclic group.